The carbonyl group, C double bond O, is in ketones and aldehydes. And then we can kind of think of it as being part of what makes up a carboxylic acid group as well. But there's one other part that's important for that. So I have 3 molecules here. We want to identify which one is a ketone, which is an aldehyde, and which is a carboxylic acid. And we want to name them as well. So first thing that I need to remember, aldehydes must always have the C double bond O on the end of one of the end carbons. It must be on the end. For a ketone, on the other hand, it has to not be on the end. So the C double bond O is somewhere in the middle, or somewhere inside. And finally, the carboxylic acid group not only has a carbonyl, but it also has a hydroxyl group. So our C double bond O also has an OH directly attached to it, and then R going off on the side. So if we look at just those 3 definitions, we can see that here we have a double bond O that's on the end, but it does not have a OH group. So that must mean that this is my aldehyde. And then my second one here, I have my carbonyl group on not the end, somewhere on the inside, and therefore it is my ketone. And last but not least, I have my double bond on the end, and I have my OH attached to that same carbon, so that is my carboxylic acid. Now we can go about naming these. So one thing to note about both the aldehyde as well as the carboxylic acids, I'm going to highlight those, aldehydes and carboxylic acids, we always start counting the carbons from the one that is attached to the end oxygen. So if I start counting on my aldehyde here, here's where I circled that group. So this is my first carbon, this is my second carbon, third, and fourth. And then with the carboxylic acid, here's that double bonded O, so that makes that my first carbon. Here's my second, and here's my third. My ketone, I just need to use the same rules I normally would and start counting from the side that's nearest to whatever special thing I have. So in that case, the only special thing I have is my carbonyl group. So I start counting here, 1, 2, 3, 4, 5. So each of these has a different number, and they go kind of in order. So I've got a 3 there. That's a prop as my prefix. Oops. And that went funny. Let's try it again. Prop. And then I've got 4, so that's bute. And then I've got 5, that is pent. So those are my prefixes based off of the total number of carbons in the main chain. And then I have to think about how we specially name each of these other bits. So let's look at the aldehyde first. Aldehyde, the special part of their name is the Al right there, and that actually gets put on the end of my my name as a suffix. So we would have bute, and instead of ane, I have butan al. Al, just like the Al right there. Oops. Okay. Ketones, and rather than the first part of the name, I'm going to take this last part of the name, the O-N-E, And I have to make note of what carbon it's on. I didn't need to do that with the aldehyde because by definition it has to be on the end. So I didn't need to say what number it's on. It's always on the first one. Same with the carboxylic acid. It's always on the first one, and so I don't have to write the number for it. But this ketone I do. So I'm going to have a 2 in there for sure. And my suffix this time is that ONE on the end. So I have pentan 2-one. Or I could say 2-pentanone. Either way would be fine. And finally, my carboxylic acid, I have an oic acid as the part of my name. So that one's split up a little bit more. So prop is my prefix. I don't need a number because it's always on the first carbon. So I have propanoic acid.